All right, let's let that load up. There it is. Okay. So if you're seeing my screen, we can do just some basic function analysis here. Let's start out with something relatively simpler. Let's say it's something like x squared plus 4x. And I asked you to determine the value of f of 1. Do you have any idea what this is referring to or how to do something like this?
Not off the top of my head, no.
Okay, so I'll show you an example here. You're gonna wherever you see an x, you're gonna replace it with the value of 1. So in this case, 1 squared plus 4 times 1, something like that. Okay. Now notice I'm doing it in parentheses. That will become more important when it's negative values, but for positive ones, it doesn't really matter. Order of operations now. Do you square, add, or multiply first?
Square.
Square. Okay, so 1 squared is 1. Then you can multiply. 4 times 1 is 4, and add together to get 5. Is that okay? Is that clear?
Yeah.
All right, so let's have you try f of 2. Okay, what is f of 2? I'd like you to evaluate that in this function, please.
Uh, 12.
Okay, so 2 squared plus 4 times 2. So notice with positives, really doesn't matter if you have parentheses or not. 4 plus 8 is 12. Good. Okay. Now where this becomes more difficult is with negatives. Okay. So I wrote down x squared plus 4x. So if we're evaluating f of -1 as an example here, if I write -1 squared without parentheses, okay, the issue is well, are you squaring 1 or are you squaring -1? This is why it's so important to put it in parentheses. Okay, so that you actually do the order of operations correctly here. Now, what you could do if you're a type of student where you're like, well, I'm not sure I'll remember that, is you can actually put the variable in parentheses from the start. And then you see that natural flow where the number is inside parentheses. Right, so now you're squaring -1. -1 times -1 is +1. 4 times -1 is -4. 1 plus -4 is -3. All right, so if you got that down, will you determine f of -2 for us, please?
Yeah. I got -4.
Okay. So -2 squared is 4. -2 times -2 plus -8, and that is -4. Good. Okay. Yeah. Now you might be wondering, well, why are we doing this? And in the case of quadratics, if we were asked to graph a quadratic, we need some data points. Okay. And typically you'll see something like this. You'll see we'll just make another function. Let's say our function is x squared plus 1. We need a table with 5 values in it. Okay. So have you seen this before in class?
Yeah, you need to find like a middle point. And
Yeah. Yeah,
Yeah,
and so
0, 1, 2, and then -1, -2.
right, and to find these y values, it comes down to your ability to evaluate the function correctly. Okay, so you have to find okay, well, what is f of 0? What is f of 1? What is f of 2? Now f of 0 here is 0 squared plus 1, okay, which is 1. F of 1 is 1 squared plus 1, that's 2. And then f of 2 is 2 squared plus 1, which is 5. So we got some values here. All right, now I recommend doing the positive ones first because they're usually easier.
Yeah.
But now the negative ones, you just gotta be really careful here. -1 squared plus 1. Can you tell me what that results in?
Uh, 1.
That the -1 squared is 1. How about the plus 1?
Oh, wait. Wait, is it -1?
-1 squared is 1, but then you're adding 1 to it.
Oh, 2.
2. Now, do you see how there's already a 2 in our list?
Yeah.
So there's some symmetry there, and we're going to take advantage of that. F of -2 is -2 parentheses squared plus 1. Can you tell me the result of that?
5.
Okay, and then that's the same as this other one. And again, there's symmetry there. So you said something very important earlier. You said you got to find the middle number, and then you go two above, two below, and that's how you graph this thing. Okay, and that's what I understand is going to be the focus of our lesson for today is some of this there. So it goes back to your ability to evaluate a function. Okay, now let's do a quick sketch of this graph just to see what it looks like here. Here is 0, 1, 1, 2, 2, 5. And then by symmetry, you see the -1, -2. You see that it's directly across from the other point. And then -2, 5. See how it's directly across from the other one there. There is some symmetry there that you can take advantage of. All right. Any questions on that? Starting out today?
No.
Great. Okay, so let's take a look at another one here. Let's say I wanted you to graph something like f of x equals x squared minus 2. Okay, so what I'd like you to do is fill in this table: -2, -1, 0, 1, and 2. I recommend starting at 0, 1, and 2, then going back and doing the negatives. Please ask me some questions if you're not sure, but go ahead and give this one a try, please.
All right.
let me know if you want to check any of your answers that you've got so far.
All right. All right, I got all my points.
Okay, let me go ahead and ask you, give me the one for 0. What's f of 0 here?
I got -2 for y.
Good. How about at 1
-1,
and 2? F of 2.
2.
Now, by symmetry, these should be the same. Did you get 2 and -1 for these?
Yeah.
Great. So a quick sketch of this reveals that it's a parabola. The order of graphing really doesn't matter, but there's there's a few ways to do it where maybe you can help with the symmetry here. You want to draw a nice smooth curve through the points. You don't want it to be too straight liney, just something that resembles a bit of a U. Any questions on that?
No.
Okay. So there's obviously a lot of functions that we could graph. Do you have your textbook handy with you?
Yeah.
Can you tell me any functions that you see on there? And I'm going to actually grab a picture here of the different types of parent functions that you might see on there. So let me do that real quick here. You can just tell me if you see any of these in your book there in that section. Do any of these, are they emphasizing one or more of these than others?
Um,
Like we just did a couple of quadratics. So there's square root, there's cubic, absolute value, anything like that.
some of these don't even look all too familiar to me. I'm seeing some rational, I think, and
I'm sorry, say that one more time. What are you seeing?
yeah, I've seen irrational, I think, and logarithmic for sure,
Okay.
and exponential.
All right. So let's do a few more of these. Yeah. Okay, that's good. All right. So let's say pick a good one here. Let's say y, and we're doing functions here. Let's do f of x equals, I don't know, let's go 2x over x squared plus 1. Okay, so this one's a bit more complicated than the ones we've been doing. Let's just say I wanted you to find f of 0. Okay, so that's 2 times 0, 0 squared plus 1. What is 0 divided by 1? Do you remember that? Can you tell me that?
0.
It is 0. Okay, very good. How about f of 1 here? 2 times 1, 1 squared plus 1.
Just 1.
Yeah. Now notice how these are working out nicely at the moment.
Yeah.
They don't always work out nicely though. Okay, and that's kind of our intro to rational functions here. Okay, so rational functions, you can think of them as almost like a polynomial over a polynomial. Okay, so like for example, we just saw in the previous problem, this 2x is a polynomial, it's a line, x squared plus 1 is a quadratic. It's a polynomial over a polynomial. Okay, now the most basic type of rational function that you will see is 1 over x. Okay, so this one, 1 is a polynomial, it's just a constant, x is just a line. But when they're put into this format, the graph looks much different than expected. In fact, it has this sort of shape to it here. All right. Now, if we were to make a table, quick table here, x and y, and we were to put in those same values we've been using before, we're going to see that there's a problem right away. F of 0 equals 1 divided by 0. Are you allowed to divide by 0 in math?
Me can, but I mean, no.
This is one of those things that is never allowed. This is not possible. Okay, and it's like, well, what does that mean? Well, we'll get to that in a moment, but this is maybe the first time you've seen that here. Sometimes the graphs don't connect. Do you see how this graph here, this one goes down, and it's like it pops back up here and comes down forever?
Yeah.
And it's not like, I don't know if you ever played Pac-Man where you go off one side of the screen and then you come back on the other, or other games. Like, it's not like that. Like they're completely disconnected. It's like you never you go down, that one goes up, they never connect here. So we'll talk about what that actually means in a moment here. But some of them we can do. F of 1, that's 1 divided by 1. That's 1. Very good. F of 2, okay, 1 divided by 2, that's fine. No big deal there. How about f of -1? Well, that's 1 divided by -1. Can you tell me what the result of that is?
1.
-1.
-1.
And then f of -2 is 1 over -2. What does that become? And I'm just asking, like, if you're not sure, or this looks totally unfamiliar, that's fine. I'm just trying to gauge where your understanding is.
Like -1/2.
-1/2, yeah. Okay, and we said at 0 that it's not possible, so that's called undefined. Undefined. Okay. Okay, so the graph looks like this in the top right. That's okay. Let's look at another function here. Let's say f of x equals 1 over x plus 1 now. So if we make a table, again, x, y, -2, -1, 0, 1, and 2, and we put those values in for x, okay, so like f of 0 would be 1 over 0 plus 1, which ends up being 1. F of 1 is 1 over 1 plus 1, 1/2. F of 2 is 1 over 2 plus 1, which is 1/3. But at -1, we're going to see that there's a problem. Okay. The problem is that -1 plus 1 is 0. You cannot divide by 0. So this is again undefined. Maybe you've even graphed or looked at these sometimes on your calculator, and you might even see like an error or something like that. We got to figure out, well, what does this even mean? And we'll do that in a moment here. F of -2 is 1 over -2 plus 1, which is 1 over -1, which is -1 there. Okay. So any questions on that before I do some graphing with you?
Yeah.
Okay. All right. So let me new share something here with you. All right. So we're going to call this y equals 1 over x minus a. We're going to add a little slider there for a. X equals a, like that. We're going to change this to, let's see here. Let's make that a dashed line like that. Great. Okay. All right. So if you're seeing my screen, make sure you see my screen here. We're looking at a rational function here. So notice that from the right here, it goes up forever. From the left, it goes down forever. This green is kind of this like separating line. So notice if I change this value of a, okay, like let's say I make a 2. Sorry, that was wrong there. Do you see how this green thing moved?
Mm-hmm.
And if I start moving it around, see how that green line moves with it?
Yeah.
Okay. So what does that all mean? Well, it's telling you that there's a place that's always undefined, and it's where the bottom is 0. It's the separator between the two graphs. Okay. So in math, it's called an asymptote, vertical asymptote. Have you heard that before?
No.
Okay. So this vertical asymptote represents this division between the two parts of the function, basically. And depending on where it's 0, that's where it occurs. Okay. So you'll be seeing that relatively soon here in a classroom, hopefully. Do you have math on Mondays?
Yeah, I have it every day.
Every day. All right. Okay, so when we're looking at a rational function, something of this form, 1 over x minus a, where the bottom is equal to 0 is called a horizontal asymptote. I'm sorry, vertical asymptote. Boy, I am off today. Vertical asymptote. Okay, so let's do an example. Let's say I tell you the function f of x equals 1 over x plus 2, and I ask you, I say, where is the vertical asymptote? VA, vertical asymptote. Your answer is, well, it's where x plus 2 equals 0. Okay, and I'm sure you know how to solve this equation. X equals -2. Now, from previous course, or maybe earlier in this course, do you remember that x equals a number is a vertical line? Do you remember that?
Yeah.
And that's what we were graphing here. So like if we were to graph this, we would go over to -2 and draw a vertical line. Now we're going to do it as a dashed, like that. Okay. And for now, we're just going to say, okay, it's that, and it's that. Okay. But your instructor wants to see the graph of that vertical line there, x equals -2. All right. Okay, so let me give you one to try here. Let's say f of x equals 1 over x plus 5. Can you tell me where the vertical asymptote is on this one, please?
-5.
So it's an equation. You have to say x equals -5.
-5.
Yeah, they want the whole thing there. All right, good. Okay, now some questions for you to think about here. Do you think it matters what I put in the numerator? Do you think that affects what goes on here?
No.
It does not here. We're going to go back to the graph there to look at that. So let me know when you can see that. There it is. Okay, so let's change the numerator. I'm going to now make b also really anything we want here. Let's see if I can get a slider. So if I change the value of b, notice that it has no effect on that vertical asymptote. I can do whatever I want. It just moves around. Okay. Well, what if I add an x in the numerator? Does it change the vertical asymptote? Does that green line ever change?
No.
It does not. Okay. Now there is an exception we'll get to at some point, but you like the simplest sort of like, I don't know if you ever done a Quizlet or made like flashcards here. To find the vertical asymptote, you set the bottom equal to 0. Is that okay?
Yeah.
All right, now I'm going to switch this. I'm going to use a different letter here. I'm going to use H. And I'm going to use K for something different that I want to show you here. And All right. Sorry if the screen's getting a little busy, but this is important here. Okay, so what do you notice about this black line here? Especially when I start moving this around.
Seems to always be like right in between the two lines, like where they
Exactly.
turn.
And what if I move this other one? Does that still happen?
I mean, yeah, there's moving across the black line.
Yeah. So it doesn't really matter what's happening here. That black is always staying in the same place or moving up and down. If I only move one, it stays the same, and so on. So, okay, great. I'm glad you can see that, because sometimes students are, they're like, they don't have any idea what I'm doing there. Let me show that. So here we go. So here's kind of the general form of a rational function. It's 1 over x minus h plus k. All right. And you probably saw h and k when you're graphing quadratics, maybe absolute value functions. Is that true? Seen those before?
Yeah.
Okay. So just review here. The vertical asymptote is where x minus h equals 0. Okay. The horizontal asymptote, which is what we were seeing in that black line there, it's always where y equals k. Okay, so as a math student, I remember not liking these where we didn't have some numbers. So let's give me an example here. Let's say it's 1 over x minus 3 plus 2. Okay. Your vertical asymptote, you're setting x minus 3 equal to 0. So x equals 3. Your horizontal asymptote is when y equals 2. So just I want you to stare at this and make sure that you see the mapping. See that h is x equals 3 is h, y equals k is 2. You're setting the bottom equal to 0 for the vertical asymptote. For the horizontal, it's this other number off to the side there.
Okay.
Is this okay? Is it kind of clear what we're doing?
Yeah, I think so.
Okay, now we're doing all this so that we can graph these things. Okay, so in this example on the right, it has a vertical asymptote at 3 and a horizontal asymptote at 2. See, I've sort of like got these new crosshairs there.
Yeah.
And then we can graph, kind of just rough sketch the picture like that. And it's based on these two numbers. X equals 3, that's the vertical one, and y equals 2 is the horizontal one there. Is that okay?
Oh yeah. Okay.
All right, so let's do another example here together. Let's say I want you to graph f of x equals 1 over x plus 1 minus 2. Okay. And I want two things. I want the vertical asymptote and then the horizontal asymptote. So the vertical asymptote comes from setting the bottom equal to 0. Can you set x plus 1 equal to 0, please, and solve that for x?
-1.
X equals -1. And how about the horizontal one?
Equals 2.
Y equals -2. Why is it -2?
-2.
It's whatever this number is, including the sign. Okay, so x equals -1 is a vertical line here. Y equals -2 is a horizontal line there. And kind of just like we've done before, you're going to graph in the top right and then bottom left there.
There.
So here's what my expectations. Here's what I'm trying to get you to be able to do. I'm going to give you a function like I've been doing. I want you to be able to tell me the vertical asymptote, the horizontal asymptote as the equations, like x equals a number, y equals a number, and I want you to be able to graph it. What about this do you feel like you cannot do at this point? So we can review if needed.
Probably the actual math, just because graphing isn't as hard for me, but
So just to be clear here, this -1 comes from setting the bottom equal to 0. This y equals -2 comes from the other number. There's nothing more to do than that. The vertical asymptote's a line going straight up and down. The horizontal is a line going left to right.
uh,
So I somehow, like, you have to put this into short-term memory to be able to do this, because I mean, obviously I want to give you some practice problems here, but I don't want to give them to you until you feel comfortable doing this.
yeah, I think I can do it.
Okay, so let's try another one here. Let's say f of x equals 1 over x plus 3 plus 2. Okay, so again, I'm looking for 3 things here. Vertical asymptote, horizontal asymptote, and then, I'd like you to just make a really rough sketch here on your own. So take a minute or two here, see if you can work that out, and I'll check back with you, or you can give me your answers when you got them.
All right. All right, I think I got it.
All right, what is your vertical asymptote equation?
X equals -3.
Good. And did you put a line sort of left here of the?
Yeah.
Great. How about your horizontal asymptote?
Y equals 2.
Y equals 2. Horizontal line here at 2. It's good to label these. And then just a rough sketch here of something like that. Any questions on that?
No.
Okay. All right, so let's go back to the Desmos to look at some other things here for that. Let me go back there, new share. Here we go. Okay. So basically, you just confirmed that you understand how to find the horizontal asymptote, which is the black line, the vertical asymptote, which is the, green line. So that's really good, really, really good here. So let's just keep these 2 values constant here, -2 and +1, like that. Now, what happens, and focus on the red, what happens when I put a negative in front of that one value? What's happening there?
It seems like they're going up, like they're switching which side of the black line they're on.
And the green line as well, that's sort of like top to bottom, or yeah. So this is kind of like a reflection in some ways, kind of.
Mhm.
It's not perfect, but it's kind of a reflection there. Let's see here. Okay, so other thing to notice here is, do you see that these have an x and a y intercept?
Yeah.
It crosses the y-axis, it crosses the x-axis, but they don't always have that, okay? Like, let me put these back to 0 and 0. Does this red line ever cross the the x-axis or the y-axis? Like, do you ever see it going down to hit? Does it come up and
No.
hit? Right. So sometimes it has it, sometimes it doesn't. We'll see that flip here again. You can see it flips over and over. these are the kinds of things they're going to start asking you. And I want to do it kind of sequentially here. I don't want to just, give you a ton of challenging problems to start off. There's also some other things that can happen here, like I can put a 2 here or a 3 here or a 4 here, and some of that happens as well. There's some changes there, but we're going to build up to that. So I guess my question to your thought for you is, like, have you used Desmos? Do you like it? Do you use it in class? I really can't remember if we've talked about it before.
I have used it before in summer school when I was doing Algebra 1. I use it for geometry, but
Great. So here's my suggestion to you, like when you're doing homework, and we're gonna do some more problems, but it's always good to have a visual representation of it. Like you should, like, you want to know what your target is, and if you need to, go and graph it, and of course do your homework assignment, but kind of know what you're looking for to make sure you've got, some idea of what it looks like. All right, so let's go back and do some more problems here. All right, so let's say it's y equals 4 over x plus 1 minus 2. Okay. All right. So could you give me the vertical asymptote and the horizontal asymptote for these just right now verbally?
um, x equals -1 and y equals -2.
Good, good, very good. Okay, so you got those down. All right, so now we're going to move to y-intercepts. Okay, y-intercept. So if you recall, the y-intercept is where it crosses the y-axis. Like literally where it crosses or hits. Like, we don't know what it looks like, but it's where it hits the y-axis there. And there's something very important there. It's actually when x equals 0. Okay, so think of this as really a function. I didn't write it as a function, but think of it as f of x equals 4 over x plus 1 minus 2. So when someone asks you for the y-intercept, they're basically saying, what is f of 0? Put 0 in for x and give me the output. Okay. All right. So could you do that for us, please? Could you put 0 in for x and simplify this expression?
I mean, just 4 over 1 minus
2.
2.
Yeah. So what does that reduce to?
I mean, with the -2,
Yes, do it everything. Like add, then divide, then subtract.
there's 4 over 1 minus 2.
Okay, what does that become?
2.
2. Very good. Okay. So the some of them are pretty straightforward like this. They can become more complicated, but this is the y-intercept. Okay. Now the y-intercept is an ordered pair. Okay. What did we say the x value is for the y-intercept?
-1 or 0.
0. X is 0. X is always 0 for the y-intercept. The y value is, well, whatever the y value is that you found, but it's an ordered pair. Okay, so remember I said the vertical asymptote is an equation, horizontal asymptote is an equation. The y-intercept is an ordered pair. Like, it's not okay to just say the y-intercept is 2. Maybe your teacher will be okay with, maybe not, I don't know. But it's like they want it as an ordered pair. Okay, just like they want the asymptotes as an equation. Is that okay?
Yeah.
All right, so let's do another one here. Let's say f of x equals, let's see here, -2 over x minus 4 plus 1. Whoa. Hang on a second here. Yep. I don't know why that did that. Sorry about that. Okay. So I want you to find f of 0 for me, please. And if you have questions, please ask, but I want you to put 0 in for x. I want you to evaluate, add. This is finding the y-intercept.
Got a 1/2 plus 1.
Okay, good start. So to add fractions, you want to make a common denominator. You can think of that one as being 1/1, which is 2/2. And then you add the tops, but you keep the bottom.
Okay.
So this the y-intercept here is 0, 3/2. Okay, it is an ordered pair. It has to be an ordered pair. All right. Sometimes it's a fraction. Sometimes it's a whole number. You have to be comfortable with both. Okay. Now I know probably prefer not to ever see fractions, but reality is you'll probably get a problem or two with fractions in there. All right. Any questions on that before we do a couple more practice problems?
No.
Okay. All right. Now I'm going to slightly switch up the format on you, but it's the same idea. Okay. Let's say f of x equals x minus 7 over x plus 5. And all I want here is the y-intercept. Okay. So I want you to think that the y-intercept means you want to immediately think, okay, that means x is 0. I'm evaluating the function at 0. Can you do that for me, please, here?
Yeah. Just got 1 and 1.
So let me jump in here. It's okay to leave it like this. This is okay.
Okay. All right.
And maybe it's uncomfortable because it's like, well, maybe I should do something with that. Maybe you've been told to. This is okay. I mean, and if you're like, well, I really don't like fractions, I would also take that as a decimal.
Yeah, that's what I got, but my teacher doesn't like decimals, so
Yeah, you got to give them what they want here. Okay, and this is okay. All right. What I'm trying to get you to see is that the y-intercept means putting 0 in for x. Okay, putting 0 in for x. So what is the ordered pair here of the y-intercept? What would I write?
0, negative 7 or 5.
Very good. Okay. All right, so let's try another one here. Let's say f of x equals 3 over x minus 2 plus 1. Last one here before we move on to something else. Will you find the x-intercept? I'm sorry, the y-intercept for this one.
It's 3 over negative 2 plus 1 over I don't know, 6.
How did you come up with 6?
It's a common denominator.
Okay, so a couple ways to do this. Like, did you write 1/1?
No.
Okay, so that's one way. That's not one way to start. The other way is it's good to bring this negative up. So I would actually prefer you to look at this as negative 3/2 plus 1/1. And then you can make your common denominator of 2. So it'd be like 2/2. Does that look okay?
Yeah.
So what does that become?
-1. 4 over -1.
-3 plus 2. -3 plus 2.
-1 over 2.
Okay, good. Good. Okay, so let's just do a little bit with fractions here with the limited time we got left. Reminder, the lessons are 50 minutes here. So let's say it's -3 over 4 plus 4 over 4. Can you tell me what that becomes? You add the top, keep the bottom.
1 over 4.
1 over 4. Good. How about -7 over 8 plus -3 over 8? What does that become?
-10. Wait.
I agree. It's -10 over
8.
Does this reduce?
I mean, it should.
They're both divisible by 2. What's -10 divided by 2?
-5.
Over 4. Good. So the last type of problem we're looking at here is something like -3 over 6 plus 1. Okay. And you have to
Mhm.
make a common denominator. What would the common denominator be in this problem?
3.
It's the bottom number, So you want to make a common bottom of 6. So this one on the right becomes 6 over 6. Do you see that?
Yeah.
Because you can only add the fractions when the bottoms are the same. All right. Good job today. We're going to go ahead and stop here.